All right, so a little bit of what's going on today. We're going to do 5.5 today, and I'm going to shift. That's today. We are going to follow the schedule. Everything on the schedule is just bumped by a day. We are going to do the review on Thursday, March 9th.
Can you bring it down a little bit?
Yes.
Thank you.
Good to know. I always appreciate when someone tells me they can't see it. Now, one of these fools in this classroom said a goddamn thing. That's you guys, all you guys. You let me write with it off the screen. So the review for Thursday will be March 9th. I'm going to walk through doing the midterm practice, the practice midterm on there. And then the actual midterm will be Tuesday the 14th. And as we discussed earlier, it will be open note. Do you guys want to know what fucking Sebastian told me after you all left? This motherfucker used ChatGPT to come up with a list of things he wanted to reference for why we should do open notes on the exam. He came up afterwards and said, I used ChatGPT. And I said, what? He said, no, the first two were mine. The third one was ChatGPT, but hell is us. All right, fine. But the midterm is in person. So you have to show up and do it on a computer here. If you have your own laptop, you can do it on your own laptop. If you don't have your own laptop, all of these pop up. And on review day, in fact, if you don't, you'll walk through it on review day. I'll make sure you know how to get in. That's the schedule. And then we'll catch up somewhere down the road. There's plenty of days in the last half of the semester where I'm only teaching one subject a day. And I know some of those days are going to be like 30-minute days, unless I teach two topics. So let's take a look at 5.5. 5.5 is counting techniques. Still in probability. So a typical California license plate. Comes in the form where, where the state makes it, and it's not like you cherry picked it to say Hefe rules or some shit like that. I need that. I need rules. That would be dope. RLZ, FARLZ. They generally have a number, then they have 3 letters, and then they have 3 more numbers. And I don't know if they still do it this way, but it used to be you could make some money in prison working on making these plates. I don't know if they still do it. I don't know if they've automated it yet. I think it gives them it's like a work rehabilitation to get them back on track doing shit. I don't know. I've done everything I can to avoid going to prison. That does not mean I haven't broken the law, but we won't go into that on camera. So, how many different license plates can we make with this combination? Let's fucking learn to spell, Jones. That's the question. So if the first character has to be a number, how many different options do I have for that first character? I've got 10. 1 to 9 and then the 0. So I've got 10. That's for my number. What about the letter? A through Z, there's 26. This is not a trap. It's not a trick question. And all three of those letters could be the same, right? And then all of the last three numbers could all be 1 of 10 digits, 0, 1, 2, 3, all the way up to 9. What we do when we're figuring this out is that when we have things like this, think about how we did probability. When the probability of one thing is independent of the next, we can multiply them together. We can do that here. What this character is does not change what this character is. There's no relationship. So we're going to multiply. The number of outcomes is 10 times 26 times 26 times 26 times 10 times 10 times 10. And we come up with 175,760,000 license plates. So like if I wanted to randomly get number 1 DRJ 007. DRJ is my initials, David Richard Jones. 007 because it's fucking James Bond. And number 1 because I'm Jefe. I'm number 1. There's only one plate like that. The probability of me getting that with random assignment by the California state, when they just go, here, we're going to mail you a new license plate. When you buy a new car, they just mail you a new license plate. They don't tell you what license plate you're getting. They just mail it to you. You're like, I wonder what I'm going to get. The odds of me getting this are 1 in 175,760,000. This is why people don't like doing that. They buy custom plates. It's not much to buy a custom plate, and then you be boss.
Did you guys see the license plate cash with the word cash on it is up for like $2 million now?
That's funny.
Yeah, ridiculous.
Why? Because if you give that up, no, I guess you have it on a car, you sell the car to somebody else, the plates go with it. So I guess the plates would transfer. Who the fuck is paying $2 million? There's not a goddamn car on this planet that's worth $2 million. There can't be. Even the fastest, most awesomest cars are still in like the 100,000s range, like maybe 300,000 or something like that. A $2 million license plate. Imagine that on like a fucking beat up Honda. I would do that. I would fucking, if I had $2 million to blow it, this is a waste of time. The probability is really low getting it. And so that's what we do when we're what we do is multiply to get the results. What if we restricted repeats? What if we wanted no repeating numbers or letters? Does this change with no repeating characters? Stats class is my go off on a fucking tangent class. That's what I do in here. Just get used to it. Is there any restriction on the first character? How many different options do I have for the first character? 10. How about the second character? 26. How about the third character? 25, it goes down. So as we go down, we keep going down with the same category. The 10, when we're back on numbers, let's go use the number 0. Now we only got the numbers 1 through 9. And so we can see those drop as well. This is only 28,624,000. Why the fuck would you give a shit about that though? Who in here likes Mega Millions?
Only playing when it's big.
That's how I am. It's got to be like at least 9 digits. It's got to be, and 100 million isn't enough. It needs to be like 300 million for me to be like, fuck it. More of a, I don't want to stop and waste my time getting out to get a lottery ticket better than anything else. I can afford the $2. I'm just lazy. Mega Millions. For those of you that don't play the lotto, which sounds like a lot of you, you get to pick 5 numbers out of 70. And then you pick 1 mega of 25. So it's kind of like bingo for the first 70. So we can calculate the number of winning, or not winning tickets, but the number of possible tickets. The first ticket can be any number between 1 and 70. And for the next 4, like if I pick 70, I can't pick 70 again. So there's only 69 numbers left. And so this kind of does like what we did up above with the license plate, at least for the first 5 numbers. And then we get to the Mega Million, and it's got its own barrel. It's got its own barrel of numbers. It's got 25 numbers in there. And where is my calculator? There it is. Times 10 to the 10th power. This is scientific notations. When this exponent, what it really means is grab the decimal point and move it that many times. If it's a positive exponents move right, negative exponents move left on the decimal point. So I've got 3.63. Let me write it down a little bit lower. And I'm going to move it right 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I throw some commas in there, we see that this is 36 billion 309 million. And I'm sure there's something besides the zeros. But my calculator doesn't show 'em. And I don't want to take the time to multiply by hand. Fuck all that. The Mega Millions website will tell you you have one in like 325 million chance. They're fucking lying. I don't know who the hell did the math on that website. It's some bullshit lies. Well, no, because you don't have to pick them in the same order. That would be a little bit different. That's how many possible tickets there are. So the probability of winning, having a winning ticket with just one ticket is 1 over that value. 36.3 billion. And if I write it as a percentage, just to make it look a little bit smaller. This means moving that number left 9 times, or the decimal point left 9 times. That's why sometimes it gets really, really big. Because you literally are more likely to get struck by lightning probably a couple times than winning the lotto. But if you can get it high enough, Mega Millions. What's going up? How to play. It says the odds of winning are 1 in 302 million. The tickets are $2 each, though. So if you want, as we will see when we do 6.1 on Tuesday, if you want even money, you want double that amount. You want the prize to be up at $605 million. Then you could theoretically, if you had enough time between drawings and enough money to buy it, you could buy one ticket that had every single possible combination so that you are guaranteed to win. There's no way to do that without hiring like a shit ton of people to do it. And so even then, like the 605 million is not really like even money. But when we get to 6.1, we'll come back to this. These are kind of like big, lofty examples. Anybody ever been on a cruise? Like where you have dinner and you gotta sit down and have dinner and they give you like options. Okay, so like a dinner cruise, they don't get, you have like, maybe it's not custom. You get choices, like a dinner cruise. Angie and I, that's my wife, we went to what's the names of the ports in Mexico there? We didn't go to Cabo. Yeah, we went to Puerto Vallarta. And we were on a cruise down to there and like we had dinner and like they will give you like you have a meal and like you can choose, I don't know what it was, like I'm gonna say it's chicken, steak, or fish. And then you probably have a side you can choose from. Probably 2, but I'm just gonna say 1. We'll say some form of potato dish. Maybe we'll say both. We'll say potato baked, potato mashed, Got your corn on the cob, which is probably not on a dinner boat because that's kind of big. I don't know, some mixed veggies and some rice. Rice pilaf. And then you might have some dessert options, like cake or pie. Okay, so if we want to figure out all the possible combinations, total different number of combination. Now we don't have something like numbers and letters where we can easily just determine it. We kind of got to count what's in each category. So the meal had 3 options. The sides had 5 options. And the dessert had 2 options. And I didn't even throw in like the drink option, like tea or coffee, or I don't know if they, I imagine they serve alcohol, but I don't know if they do in the restaurant part of the boat. Same idea as what we did before, multiply. 3 times 5 times 2 is 30. This is all called the multiplication rule of counting. Any questions so far? Don't you look at me, keep doing your physics.
This is English.
You just kind of want to just, right? It's just so yeah. It's like, quit fucking picking on me, Jones. No, he doesn't. He keeps coming up for more. He always comes up and talks to me after class. He still likes me, even though I'm constantly talking shit. Not really shit. It's more of a jealous thing. I wish I could multitask like that. I'm not ashamed to admit it. All right, next part. Looks like everybody's done writing. That's the main reason I pause so damn often. I want to give people time to finish writing. We need to go over something called factorials, because they play a part in everything that goes on here. And I think the easiest way to show you what a factorial is without words. Let me just show you what the symbols mean and what happens. If I have the factorial symbol is the exclamation point. So if we have 6 exclamation point or 6 factorial, six factorial equals 6 times 5 times 4 times 3 times 2 times 1. You just keep multiplying by the next smaller number until you get down to 1. You don't go down to 0, because then if you multiply by 0, Boom, gone, done. So this tends to, they have, there's rules for like when this isn't like a whole number, but you don't need that for this class. We're only gonna have whole numbers in this class for the factorials. The only other one that is like a little bit weird is the 0 factorial. Factorial. If I started at 0, I can't go down. They define the 0 factorial equals 1. It's just defined that way. Get over it. It makes no sense. Just accept it and move on. Buttons you will see on a calculator that do this. Some calculators have, oh, maybe I should write calculator buttons. This is bright. It's a little too bright. I'll have a button that has an X and I'll have a nice little fancy exclamation point. On like my phone one, my phone just has the exclamation point itself. So it might just be the exclamation point all by itself. Some common handheld calculators have something called the PRB button. And when you hit the PRB button, 3 options pop up. It'll say n factorial. It'll say NCR like that. And it'll say NPR like that. These are lowercase r's. And factorial is the one with factorial. Boom. These other two, the factorial shows up in these. And I'll introduce you to those one at a time. These are common buttons on a calculator too. NPR and NCR are common buttons on a calculator. Has anybody gone to Puerto Vallarta? It's in my head. We got off the boat and there's like a list of the shit you cannot bring back on. It's got your standard shit, no firearms, no knives, no bow and arrows, which I thought was a little odd. Like, who's coming in trying to be an archer? And then it said no lances. Like the kind knights ride on a fucking horse that's, they carry a long stick that's like 15 feet long and they try to knock the other person off. You can't bring one of those on board. Which means if they put it on the sign, not only is someone in Puerto Vallarta selling lances, bought it and brought it on the boat, and probably tried to cause fucking mayhem with it. It's long. It's like 15 feet long. You can't swing it like a bat. Just holding it and running down the hallway and seeing if anybody fucking stepped out. Someone had to do something stupid to get it on the wall. It's things like that that made me go, All right, you all had time to write. Let's take a look at NPR first. This falls under permutations versus combinations. Permutations versus combinations. Permutations, order matters. Combinations, order doesn't. Kind of like toppings on a pizza. You call up Pizza Hut, you ask for a 3-topping pizza. It doesn't matter if you say pepperoni first, second, or third. There's going to be pepperoni on it, and it doesn't change the amount of pepperoni. Although if you don't say it first, there's something wrong with you. It should be your first ingredient. So the order doesn't matter on things like pizza, but like, let's say we are in a race and we want first, second, and third place. Now, if I am a race car driver and I want a place in the top 3, to me, it very much matters whether or not I'm in the first chosen one, if I take first place or third place. So permutations, order matters. Anytime where you think there's an order to this shit, like I want to be first, or if I was in a, like if this is a permutations one. Permutation starts with P. Permutations leads to NPR. What did I do underlining this shit? The formula for NPR is n factorial over n minus r factorial. And I'll show you in operation what that means. In fact, we'll do it now. I'll tell you a story about my first time ever at a horse race. I grew up in Sacramento. Sacramento's got Cal Expo. It's where they hold the state fair every year. There is horse racing. One of my best friends growing up, his stepdad bet all the horses at the horse races. So we got in all the time for free into the fair, going in like the stables. And so I was like 12, and my cousin Annette, she takes me and my brother Ryan, and she wants to show us the evils of gambling. Like, don't waste your money on gambling. Mom had given her like $20 for each of us, or $30 for each of us. This was like back in 1985, a long fucking time, older than most of you guys in here. It was a long time ago. 20, $30 went quite a ways. The trifecta ticket was $2. The trifecta is you bet on, you have to pick the horse that takes first, second, and third. You bet on 3 horses, and you bet what order they're going to fucking finish in. And you have to be right. It can't be like you picked Aaron and Bill and Clyde in that order, and then Bill and Aaron and Clyde came in, like Bill beats Aaron, but you said Aaron was first, you lose the trifecta. Order matters. Payout is huge on the trifecta. She tries to show us the evils of the trifecta. There's like 12 horses in a race, maybe. I picked horses on the names, and I fucking won the trifecta. I was so fucking excited to see my 3 horses cross. Did that bitch let me have any of that fucking winning money? No. She's trying to show me, she's only a bitch because she didn't give me the money. I miss my cousin Ned. She died a long time ago. She gave that money to my mom. She was like, this was totally defeating the purpose of showing us evils of gambling. We went to the races early at the fair. So I'm like, I could hang out all this money at the fair, doing all sorts of fun shit. No. So trifecta, if there's 12 horses, I can do both, tell a good story and talk about doing it. The way NPR works, N is the total number available as it's been in everything we've done, and as the population, basically. R is the number selected. And we will do NPR without doing the formula first. I will show you how it matches up. If I got 12 horses I can bet on, how many different horses can I choose for first place? 12, right? First place can be 12. What about second place? 11. The same horse can't win, take first and second. That would be some creepy ass, like cut in half horse shit. That's not cool. Third place, 10. 12 times 11 times 10. Wait, I can do this. 132 times 10 is 1,320. Our work. That's not using NPR. This is not National Public Radio. It is the permutations option. NPR setup for this is 12. That's the total number available. This is my N. The number of horses I'm selecting is 3. That will be my R. So I will have 12P3. And you will hit them in that order on a calculator. I'm gonna have to do the calculation on the next page. So if I were to put this in a calculator with the NPR button, I would do 12 NPR 3, and then I'd hit equal. And I told you the formula for NPR, and I'll rewrite it down again. If I do 12P3, I have 12 factorial on top. 12 minus 3 factorial on bottom. Sometimes having to pull out the calculator is actually slower than doing this shit. Because this is kind of neat. 12 minus 3 is 9, so I've got 9 factorial. And you're like, that's a lot of shit going on. Well, let me write out the top. I could write out the bottom, but I want you to think about things where you can do it quicker. This right here is 9 factorial. So 12P3, 12 factorial over 9 factorial is 12 times 11 times 10 times 9 factorial over 9 factorial. When you have stuff on top and bottom of a fraction, they cancel out and leave behind a 1. And I am left with 12 times 11 times 10. which is what we did up here. So my calculator has a NPR button down here. I'm gonna do it. I go back to the main, I'm gonna hit 12. Hit the function and get my NPR button. Oh, it works differently. Maybe I gotta do this different. I gotta hit NPR and maybe put 12, comma 3. Stupid calculator. It does it completely different. So mine, I had to put it like that. And it gives me the 1320. So your calculator will do the work. Sometimes they do it differently. Most of them that isn't cell phone related, you do the N first, then hit the button, then you do the R. Now, that was the trifecta, and that's what I won. What is the probability of winning that trifecta? I have one ticket. Probability of winning the trifecta with 12 horses. Well, I had one ticket, that's the total on top. The total number of combinations was 1,320. Which ends up being 0.00758. Or less than 1% chance. Trifectas pay out good money. But you don't hardly ever hit them. That's where order matters. Horse races, if you're picking people in a class and order matters. Like if I randomly pick 3 people, the first person is guaranteed an A+, the second person is guaranteed an A, the third person is guaranteed an A- for the whole class. You're like, pick me first. I want the A+. If order matters, you use permutation. If order doesn't matter, we use combination, which is NCR. Order doesn't matter. Think pizza, like a combination pizza. They call them combination pizzas. It's kind of easy to remember that. I call them fucking supreme pizzas now, don't they? Those damn bastards. Some of them call them combination pizzas still. The only difference between NCR and NPR, they both have the N factorial on top. They both have N minus R factorial on bottom. NCR has another R factorial on bottom. I guess we could do the lotto thing right here. Lotto is another example, at least for the first 5 numbers. It doesn't matter what order you pick them in, as long as you pick them. So let's take a look at doing the Mega Millions. People are still writing. I'm sorry. I'll give you guys a second.
Are we gonna have to remember all these formulas for the final for the midterm?
If you're not writing them down, yes, you do. Do you forget the whole open note thing that you
No.
got Sebastian to Jedi mind trick me with ChatGPT? Still fucking bitter about that. I don't dare tell other teachers that I got duped by a fucking high school student using Chat GPT. I mean, I was laughing stock of the fucking math department.
It was only for the last one.
That's what he claims.
You don't believe me?
I believe you. You don't have any reason to lie. If you're gonna lie, you would have lied a long time ago and said, no, I've been taking notes the whole time. No, I'm not doing my English homework or my fucking physics or insert any other class but statistics. Lied then. So no, I don't think you're lying. But you're ruining my fucking story when you say that. Quit ruining my story. All right. Mega Millions. Pick 5 out of 70. Any order. And then pick 1 out of 25. So the 5 out of 70 order doesn't matter. This becomes 70C5. The 1 out of 25, there's just 25 different balls to choose from. I'm going to multiply that by 25. And I'm going to see how far I can take this before I need a calculator. Just to illustrate something. The 70 choose 5. That's actually how they read it. They say 70 choose 5. Or N choose R. So if you hear that, they're doing NCR. If I do that, I have 70 factorial over R factorial is 5 factorial times N minus R, 70 minus 5 is 65, 65 factorial. And then I still have a 25. A lot of this shit's going to cancel out, actually. I've got 70 times 69 times 68 times 67 times 66 times 65 factorial. I'm going to write out the 5 factorial as 5 times 4 times 3 times 2 times 1. And then we've got the 65 factorial still. And I still got a 25. And I'm just going to start canceling shit out and seeing what I'm left with. The 65 factorials go away. Five goes into 25 5 times. Three times 2 is 6. 6 goes into 66 11 times. I can cross off the 3 and the 2 and the 66, and I'm left with 11. And all I've got left on bottom is a 4. Is anything there divisible by 4? Yes. 68 is 4 times 17. 4's canceled. So this should be 70 times 69 times 17 times 67 times 11 times 5. Let's see if those mega million people are lying fuckers or not. What do you know? They were telling the truth. 302,575,350. If you have a calculator with you and want to try it, I would do 70 NCR 5. Then I'd hit equal and I'd get an answer here. And then I'd multiply that by 25. My calculator is a little bit different. I gotta do that stupid button over here. And so both ways I did it, using the NCR button or doing the cancellation like I did. I got the same number. I don't know if you guys can see that though. One of those doesn't even need the NCR button. You just do a little bit of math magic, clean it up, and you get it. You guys ready for more? Don't anyone say yes. You're not ready for more? Keep writing this. Tell me when you're ready.
Oh, yeah. I'm ready for one.
Lied to me is what you did. Like
I
fun.
thought we were gonna stop. Yeah, that's what I thought you meant. That's
Oh,
exactly
no.
what-
We got a little bit more in this section to do. When we're done with this section, we'll be done. Did anyone need it up longer? Okay, so let's take another example we want to look at. Let's say we've got 30 students. And I've got 18 girls and 12 boys. We're going to assume everyone categorizes themselves in one of those two genders. I know that's not true in society, but to simplify shit, that's what we're doing. If I select 4 students, at random, what is the probability that at least one is a girl? So I'll let you write it down and we'll think about what this is really asking and think of, is there an easier way to do it? The probability that at least one is a girl means I could have 1 girl, 2, 3, or 4. second.
Isn't that what cheese? I think so. That one too. The starter one, the one.
If I do this the way that it's done, I need to do the probability that one is a girl, which would be just doing probability one is a girl. Means the first is a girl, second equals boy, third equals boy, fourth equals boy. Or I can just start going through them. The first one's a boy, but the second one's a girl. And then the third, fourth are boys. There's a lot of ways to go through this combination. Boy, boy, girl, boy, and then boy, 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 girl. And each of those is an or. And doing the rules of probability, I have to add them all up. And that would be just finding one, probability of that one. I want to do at least 4. So, or at least 1, which means doing 1, 2, 3, 4. There is an easier way to do this. Because the only other possible option I have out of picking 4 students, this is a dead pin after today. Pick 4 students. I could have 0, 1, 2, 3, or 4. And what I've been asked to do is do this one. So if I do probability of 0 girls plus probability of at least 1 girl, that covers the 1, 2, 3, 4. Probability adds up to 1. So if I want probability of at least 1, I can subtract that P0 over and do 1 minus P0. The probability that 0 of them are girl means all boys, right? Zero girls means all boys. I've only got one combination I need to do. One probability setup. I will show you how this works with NPR, NCR in a second, but I think this problem is a lot easier without it. If I want to do 1 minus the probability of all boys, we're going to use some of those rules I had you watch the video on. 1 minus probability of all boys means the first is a boy and second is a boy and third equals boy and fourth equals boy. I'm only writing this out because that way hopefully it looks like some stuff we did before. The and turned into multiplication. We started this off with saying there was 18 girls and 12 boys, total of 30 students. For the first student that I draw, what is the probability of getting the boy? There was 12 boys available out of 30 students. Then the second one, we've already chosen a boy, so there's only 11 boys left, and there's only 29 students left. The third boy, we already chosen 2 boys, so there's only 10 boys left. And we've already drawn 2 of the students, so there's 2 less. There's 28 students now. And if you follow the pattern, you'll see that the next one is 9 and 27. Now, if your calculator does fractions, you're going to get 1797 out of 1827. This is 0.982. I think reasoning it out that way is easier than doing what, or remembering to do what follows. The same way to do this with NPR and NCR is we are doing an area where the order doesn't matter since I'm doing all boys. So to do it with the other method, you're going to do 1 minus choose 4. So that's the boys on top, over 30 choose 4, and that's like all students on bottom. Calculator, you will get that same 0.982. I have a hard time remembering to do this. I teach this shit and I still have a hard time remembering doing it this way. This way I can reason out how many are left. I can count them. I can literally draw out 30 students, label 18 of them G, 12 of them B, cross them out as I draw them and see what's left. I can follow along with what's going on here easier than I can do remembering this. But if you're good at memorizing shit, like Sebastian's probably good at it, that's probably the shorter one. It's definitely quicker. I didn't have to reason shit out. I just had to go, how many boys did I have and how many boys was I choosing? Divided how many students I have, how many students I was choosing. I just don't work that way. I don't remember it that way. I remember like what's going on at each step. You're free to do either one. We got one more topic. Because everything we've done so far, has required n distinct objects or people or whatever we're talking about. If we're talking about the toppings on a pizza, pepperoni is one topping. The whole thing doesn't work if I say pepperoni 3 times. Is what we were doing before. What if you just had like 3 different colors though, and you were working with 3 different colors? So like, let's look at an example where we have repeats. If we have repeats. Like slide, you've got 10 marbles. They still sell marbles. I know they do. We found a marble in my mom's shit the other day. I don't know who still plays with marbles, but they sell them. Let's say 5 of them are red. 5 are not 5. 2 are green. And 3 are blue. And I'm going to draw them all out and I'm going to set them in an order. The order I draw them, I'm going to set them down. That's 10 slots. I've got 3 colors that match those colors. So let's say I'm gonna I draw the 5 red balls. I don't know what order they're gonna appear in, but let's say like a red appears here. There's 2 reds here. There's a red there and maybe a red there. The number of ways I can place the 5 red balls is 10 choose 5. There was 10 positions and I'm occupying 5 of them. If I do the green next, let's say the green are late in the game and they're placed right there. I had 2 green balls. I only had 5 spots left to choose from, and I picked only 2 green balls. And finally, my 3 blue balls, I didn't have a choice. They all just picked a spot and they went in. It's 3 choose 3. And so the number of combinations doing that multiplying rule accounting we did, we multiply these to find out what we get. Total options. Ten choose 5 is 10 factorial over 5 factorial. And 10 minus 5 is 5, gives me another 5 factorial on bottom. That's my red, that's my 10 choose 5. And then I'm going to multiply it by my green. I had 5 choose 2 is 5 factorial over 2 factorial times 3 factorial. And that was 5 choose 2. And when we get to blue, we've got blue was 3 choose 3. So 3 factorial on top, R was 3 factorial, and then N minus R is 0 factorial. I'll pause for a second, let that soak in. I'm just showing you how you can come up with the formula if you don't remember like the next formula. It requires you to know the last of these formulas. But what cancels out here? The 3's do right here. I can see it, right? 0 factorial is just 1. I don't even need it. What else cancels? A 5, right? The resulting answer is 10 factorial over 5 factorial times 2 factorial times 3 factorial. Or maybe I should do it with the colors I used. 5 factorial. Green was, the 2 was in green. Maybe I should have crossed out that 3 instead of that 3. Because I want to have the blue 3 there. So if you want to arrange combinations of repeating objects, let's say you've got k different groups. And each group has their own n. Each group has their own n. Like n1, n2, n3, nk. The formula for it is the total factorial over n1 factorial, n2 factorial, dot, 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 times nk factorial. We can see that with what we just did here. N1 was my red group. N2 was my green group. Where's my green pen? And N3 was my blue group. And I had 10 factorial over 5 factorial, 2 factorial times 3 factorial. You still got to multiply it out and do it, but there's a formula. And that's all I've got for you today, folks. You are now free to roam about the country. Why does everybody always sit on that side of the room? But I guess the screen's on that side of the room. So it's easier to see if you sit on that side. I guess I could have taught like this during the pandemic. No one gets within 20 feet of me. They're like, hell no, you crop dust us. Fuck that. That's it. If there's any questions, feel free to ask. You are free to go, or if you want to work on homework, you can stay here. We will do work on chapter 6 on Tuesday.
Okay.